Hi everyone, my name is Frolov Ilya, and today I want to read about recycling plastic because I have idea in this uh, Saturday make clean up in my city. And today I want to read information from a website Precious Plastic. Mm, so I have several texts, several pages. Let's start. I think health hours enough. Welcome to the Precious Plastic Academy. Awesome to see you interested by recycling plastic. We have made this section of videos, tutorials, and content to share the most critical things we have learned over the last years about transforming plastic waste into valuable products. We will teach you about the basics of plastic, what types there are, and how to identify them, to collect and separating plastic, to building your own machines, business models, and you adopt how to become an important numbers in the precious plastic community, and much more. We have created download packs and templates, and once you've gone throughout everything, you will be ready to start your own recycling workplace anywhere in the world. Um, but wait, why did you do this, and why it is all for free? At Precious Plastic, we want to show the incredible opportunities of plastic waste in order to eliminate plastic pollution, recycling the demand for new virgin plastic, and closing its material loop while cleaning better livelihoods for people around the world. Precious plastic is, above all, a cultural tool to change the way society perceives plastic. All plastic laying around you is a resource, not waste. It is a material with great potential left intact all around the world, and if processed correctly, can become something new and valuable. This resource can become a source, is income, or an education tool for your community, at the same time making sure it doesn't enter our environment. We have created machine documentation, video tutorials, campaigns, and platform to improve people across the planet to start working with plastic waste locally while trying to disentails and localize plastic recycling technologies, infrastructure, and knowledge by providing open source designing for machines, molds, and consumer products, as well as business models and tools for you to set up and run a workplace. We share something open source for anyone to benefit from. This means that all the knowledge, know-how, process, methodologies, methodologies, and tools are available online for free at all times. This open source psychology is at the core of precious plastic and shapes most decisions within our team. We believe that collaboration is stronger than competition, and that the plastic problem can only be solved collectively. Are you interested in the connect with the precious plastic community? Perhaps you want to learn more or share your own knowledge. You are in luck. We have created a Discord to discuss all the things we have doing here. Check out the questions section in the sidebar to see where you can chat with people locally and globally. Ok, let's drive it. Drive in. Um, the basics of plastic. Let's start from the beginning. What is plastic? Where does it come from? How much do we use and what is recycled? The different types of plastic exist and how do you recognize them? Here we cover the basics of plastic to get out up to speed quickly with a material you're going to be working with. Prototype. Look under your plastic products and see if you can recognize what type of plastic it is. What is plastic? Plastic is everywhere around us. The word plastic is in our monthly day in day out, but what does it really mean? The word itself is derived from the Greek um, plasticus, meaning capable of being shaped or molded. Uh, there refers to their malleability during manufacture that allows plastic to be cast, placed to extruded into a variety of shapes like films, fibrous plates, tubes, bottles, and much more. Uh, Plastic synthetic chemical extracted mainly from petroleum and made of hydrocarbons, chairs and chairs of hydro- hydrogen and carbon atoms. Most plastics are polymers, long molecules made up of many repetitions of basic models called monomer, and these structures make plastic particularly durable and long lasting. Due to their relativity low cost, ease of manufacture, and versa- versatility, plastics are used in an enormous and expanding range of products, from shampoo bottles to place rockets. The UB, U, um, ubiquitous them. I don't know what is it. Very difficult word. And sheer volume of plastic products. It is everywhere. Is causing serious environmental damage regarding its slow decomposition rate. Recent studies say 500 years. Due to its strong bonding molecules. Think of it this way: all plastic ever used from your parents and grandparents and grandparents are still around today and will pollute the planet for another for centuries. Most plastic contains other organic or inorganic compounds blended in called additives to improve performance to reduce production costs. The amount and additives range widely depending on the application and plastic type. So you can find everywhere in the world, and it ends up in places we definitely don't want it to be. We produce 300 million metric tons of the new plastic every year, which is not very smart, especially when you have a much already existing material what we can use. Virgin plastic is made from oil, a valuable foil fuel which we're running out of, and it's used to make cleanup product, which means to be dis- discarded after very short time to usage. It's not very smart, and as less than 10% of plastic is actually recycled. Most of all this newly produced plastic ends up in landfills, the ocean, or burned. Hmm. So, how do we solve this? Well, it's time to get recycling. Different types. Firstly, and to measure categories of plastic: thermoplastic and thermoset. Thermoset and thermoplastic. Thermoset. Thermoset plastic contains polymers that cross links together and create an irre- irreversible bond, meaning they cannot be melted once they take shape. They will be solidified forever. Think of thermoset as bread. Once bread is made, if you try to heat it, it just burns. None of the plastic can be recycled. Some examples of thermoset plastic are toilet seats, wind turbines, pan handles. Thermoplastic. Thermoplastic is a plastic polymers which become soft then heated and hard when cold. Thermoplastic materials can be cooled and heated several times. When they are heated, they melt to a liquid, and when they cool, they become hard. Think of thermoplastic as buttered. Uh, it can be heated and cooled many times. It just melts and sit again. Examples of thermoplastic: garden chairs, buckets, mm, disposable cutlery, bottles. Thankfully, 800 and 1800% of plastic in the world are thermoplastics, meaning they can be recycled and transformed. Thermoplastics, which we will just refer to as plastic, are differed into further subcategories depending on the structure and properties, and can be recognized by their name of number that should be usually printed or embossed somewhere in your products. The most common ones are: first, PET; second, HDPE; third PVC, fourth LDPE, fifth PP, sixth PC, seventh other. First, PET, polyethylene terephthalate. PET is very strong plastic that can be easily recognized for its transparent look. All water and soda bottles are made from PET, as well as some jars, combs, bags, tote bags, carpets, and ropes, and is recycled more commonly. Recently, PET has been recycled into yarns and made into clothes. This plastic is a bit more complex to work with. We advise to start with other plastic. Properties: lightweight, impact resistance, uh, required semi-rigid. Pros: strong and tough, water and oxide barrier, good electrician properties. Cons: high mold shrinkage, heat degradation, harmful fumes. Safety: medium. Warning: harmful fumes during process. Some research suggesting harmful material seeping throughout long-term use. Common uses: blow molded bowls, water bottles, soda, juice bottles, wrapping, film, electrician fitting. Best way to use these PP machines, we work on that. Second, HDPE, high, uh, high density polyethylene. HDPE is often used for food and drink containers, as well as the milk bottles, motor oil, shampoo bottles, soap bottles, detergents, branches, toys, and bottle caps. Products of this plastic type are other easier to collect, sorted, and clean. HDPE work very well with precious plastic machine and is great to start with. Properties: inert, thermally stable, touch, and high tensile strength. Pros: cheap, high chemical resistance, electrical properties, waxy feel, good friction behavior. Cons: less tough than PP, easy to burn, poor UV resistance, high mold shrinkage. Safety: good. Warning: HDPE itself, them not burning, is not dangerous to use. However, um, additives can be dangerous. It's not possible to see what kind of additives are used in products. Common use: pipes, toys, bowls, crates, baking films. Best way to use these PP machines. HDPE works very similar to PP, low melting temperature and easy to mold. Great material to use. Cool. Third, PVC. PVC, polyvinyl chloride. PVC is toxic and we don't work with it. It's most commonly found in plumbing pipes and realized chloride when heating up. We don't recommend to use it with precious plastic machines. Properties: ins insulating, chemical, inert. Pros: cheap, acid and alkaline resistance, flame retardant, tough and strong. Cons: overheating causes degradation, bring below 0 Celsius, discolored in strong UV lights, high density for thermoplastic, uh, um, H, HCl, and dioxide when burned. Safety and not safe, do not use. Warning: dangerous fillers and release of H-chlor and dioxide burning, degradation, or burning. Common use: flexible, take leather, scenes, cable covers, type, rigid, rigid pipes, building products, bottles, films, solos, heat shrinking tubes. Best way to use this PP machine: don't use it. Okay, fourth, LDPE, low density polyethylene. LDPE is largely used for plastic wrap, sandwich bags, squeezable bottles, and plastic grocery bags. Usually, LDPE is not commonly recycled as its other not labeled. It's too light and tends to be more difficult to clean, but works rather well with precious plastic techniques. A popular recycling technique for plastic bags in ironing them into a more durable textile. Properties: chemical, inert, flexible, isolating. Pros: cheap, chemical and uh, hydrolysis resistance, high impact strength, low temp, good processability. Cons: low tense strength, low toughness, low max temp, burn easily, poor VC resistance, high mold shrinkage, safety good. Warning: LDPE itself, when not burning, is not dangerous to use. However, additives can be dangerous. It's not possible to see that kind, and additives are used in products. Common used: bowls, tides, toys, containers, film, squeeze bottles, pipes, bags, sheets. Best way to use this PP machine LDB is either a foil and not ideal to shred. Not ideal to shred, but it's good to fuse together with iron or use to create marble. Okay, PP, polypropylene. It's fives. Polypropylene is one of the most commonly available plastic in the market. It is strong and can usually withstand high air temperatures. PP has a variety of used, but is consistent used for plastics that get a contact with food and drink, typeware, yogurt boxes, syrup bottles, ads. PP works very well with precious plastic. Properties. Some properties here. Pros: like PE but stronger, tougher and high temper and low density. Mechanical, thermal, and electrical performance result in a low-cost engineering plastic. Cons. Higher cons than PE, brittle below zero temperature, high permeability to gases, poor resistance to fuel, poor UV resistance, keeps burning. Safety good, warning. PP itself, when not burning, is not dangerous to use. However, additives can be dangerous. It's not possible to see that kind of additives are used in products. Common used structural parts, pipes, toys, chairs, uh, kitchen weight, DVD cases, and packaging, films, textile, carpets, rope, meaning best way to use these PP machines. Work well with all machines. We love polypropylene. Sixth, PC, polystyrene. PS is most commonly known as um, styrofoam, but also means in many more products. PS can be recycled, but not efficiently. Recycling it's take a lot of energy. This means when few places accept it. Disposable coffee cups, plastic food bottle boxes, plastic cutlery, and packing foam are more from PS. It works very well with precious plastic. It is one of the most toxic plastic types, so special attention please. But at the same time, offers great uh, aesthetic and haptic properties as it uh, comparable with glass and can be polished. Properties clean, glossy, hard stuff. Properties clean, grocery, hard stuff. Pros cheap, low multi shrinkage, good insulator, insulator, good good on low temp. Cons breach, poor wear resistance, poor chemical resistance. Safety medium, warning. While burning PC, styrene can be uh, res- uh, released toxic. Common used toys, CD cases, light diffusers, electric housing, cutlery. Best way to use this PP machine: extrusion sheets, polystyrene, glass-like material. Seventh, other or mixed type. This code is used to identify other types of plastic that are not different by the other six plastic types. Plastics such as ABS, acrylic, or polycarbonate are included in this category and can be different to recycle. However, precious plastic can work with some of these properties, as this included a lot of different plastic types. The properties can vary a lot. So it's different with a type of plastic it is. If you can identify them, you can reuse it, but if it's mixed, it's house. There are some good plastic in here to work with: ABS, PLA, nylon. Cons: hard to identify signs. The other don't have their own label, so it gets mixed in a house and its house. Safety: hard to find the melting temperature, especially if it's mixed, so you can easily end up burning it. So can so not that safe. Warning: some of the plastic types, including here, like PEC, release very toxic fumes. Make sure to inform yourself about the plastic type you want to work with and test its properties before processing it in messes. Common types: PC, CDs and DVDs, PLA, bioplastics, ABS, 3D printing filament, toys, electronic plastics, PMMA, acrylic glass. And always remember, don't mix plastic. Different plastic types should never be mixed together, as this will decrease their quality uh, drastically, drastically, really, then, and make it very difficult to recycle them. Moreover, when different types of plastic and melted together, they tend to fast separate, like oil and water, and setting layers results in structural weakness and lower quality products. Melting temperatures. So there are different types of plastic. One reason why it's so important to separate them is because of their melting temperatures. They all reach a liquid state at a different heat. So, in order to make new high quality items, it's important to know as what temperature each plastic melts, as well as at what temperatures different types can be molded. But don't worry, we did the test for you. You can find more about specific melting temperatures in the Create section, Heat to Design. But it's important to remember the different types of plastic. So we made it handily posted for your workplace or studio. Want to share feedback, chat about plastic, or learn more from community? Head to the plastic channel on Discord. Here we talk about plastic safety, fumes, and material properties. Okay, that's it for the basics of plastic. We hope you learned something. Check out the next chapter with Jerry to get even deeper into some of these plastics. Wow, very interesting text for me because very very many new words um, after classic document text. How I read, it's more technical, but um, from another side, um, more more chatting, more fluency, because here mix technical words with simple simple story. Um, uh, when we read introduction and conclusion. So we see you later. Bye. Have a good night.